Okay, so today we are beginning our chapter 7. So we're going to be talking a lot about polygons. And we're going to start out with angles of polygons. So what we're going to discuss is finding the sum of the interior and exterior angles. We're also going to look at finding the measure of just one angle by itself. So to start with, let's make sure we're clear on our definitions. So the definition of a polygon: it has to be a closed figure, and there has to be 3 or more sides. Let me change this color. All right. When you're naming it, make sure you're listing your vertices in consecutive order. So it doesn't matter where you start. Just make sure you go either clockwise or counterclockwise. Don't bounce around. So don't go B, D, C, E, A, or something like that. Make sure you find a point and you go around. So this would be A, B, C, D, E. And since there are 5 corners, that means there are 5 sides. So that would classify this as a pentagon. Make sure that you're well aware of the number of sides and the names. Notice that they skipped 11, so we're going to go over that. Since 10 is a decagon, because deca is is 10, bleh. 12 is dodecagon, so 11 would be undecagon, because most of these terms are either Latin or Greek derived. Make sure you know the difference between convex and concave. We can get all fancy talking about the diagonals are all on the interior, or if one of yours is on the exterior, it's concave. In all reality, if the figure caves in, it's concave. That's the easiest way. So if it caves in, it's concave. If it doesn't, it's not. Make sure you're aware of regular and irregular. Regular being equilateral and equiangular. They're automatically going to be convex if it's regular. So it has to have marks that look like this. Irregular just means everything's different. You can have some things the same, some things different, so on and so on. But unless everything is the same, all same sides, all same angles, then it's going to be irregular. So draw. So we're going to draw and label these polygons. So if you draw a hexagon, make sure you note that it's regular. So you have to mark the picture showing that this is regular. So that means all the same sides, all the same angles. So you get them all marked. And then we're going to name it. I'm just going to pick this corner to start with. H-E-X A-G-N. And that's all you have to do on that. In the next drawing, they want you to draw a concave pentagon, and it has the stipulation that these 3 sides have to be congruent. So if I said, well, these 3 sides are congruent, so P, E, N, T, A. Oops, that's supposed to be an A. So P-E-N-T-A. And then the last, you have convex, so nothing's caving in. It's irregular, and it has to have 4 sides. So I just threw up 4 sides. So L, A, T, E. So just make sure you're comfortable with drawing what they want you to draw. And that way you will not have any problems when you have a word problem that describing a picture instead of giving you a picture. So in this problem here, we're going to draw our diagonals. So pick a corner and draw your diagonals. So I have 3 sides here. This one I have 4. This is 1, 2, 3, 4, 5. And this one has 6 sides. If it's an n-gon, it has n number of sides. So basically after 12 sides, the dodecagon, they don't have fancy names anymore. 13 sides is a 13-gon. 20 sides is a 20-gon, 80 sides is an 80-gon, so on and so on. So once you get to 12, it just kind of loses its fanciness. So you've drawn your diagonals. So you pick a corner, you draw your diagonals. Pick a corner, draw your diagonals. So now, there is 1 triangle. So it says number of triangles, 1. Here I have 2 triangles. 1, 2, 3 triangles. 1, 2, 3, 4 triangles. Well, I bet if I had 7 sides, I would have 5 triangles, because what I notice is that the number of triangles appears to be 2 less than the number of sides. So if I have n number of sides, then that means I have n minus 2 triangles. So 2 less sides. So now the sum, or your total of your interior angles, well, if I have a triangle, we all know there's 180 degrees inside of a triangle. Well, here, if I have 2 triangles, and each triangle has 180 degrees, then that's 360 degrees. Here, there's 3 triangles. Well, each triangle has 180 degrees, so that's 540 degrees. Here, I have 4 triangles. Each triangle has 180 degrees, so that would be 720 degrees. So that must mean that the number of triangles, n minus 2, times 180 for each triangle is going to give me the sum of interior angles. Okay, so this is super important to know so we can get through the lesson today. All right, so let's take this information. So it says to find the sum. So this works on all polygons. All right, so heptagon. Heptagon is 7 sides. So that means 7 minus 2, which is 5. 5 times 180 is 900. So the sum of interior angles is 900. A 15gon, well, that means n is 15. So 15 minus 2 is 13. So 13 triangles times 180 per triangle gives me 2,340 degrees. So a 15gon has a total of 2,340 degrees. Now, if I only want to find one, so just one, this only works on regular polygons, so it has to be regular. So first thing I have to do is I have to find my total, which is this, and then divide by the number of sides. So a hexagon has 6 sides, so I need to find my total. So total is 6 minus 2, which is 4 triangles, times 180. So that's 720 degrees is my total. So 720 divided by 6 is 120 degrees per angle. So every angle in a regular hexagon has 120 degrees. In a triangle, well, we know a triangle's total is 180. We know a triangle has 3 angles. That's why every angle is 60 degrees. So depending on your polygon, your total is always going to be different. When you are looking for the sum or total of exterior angles, it doesn't matter. This goes to all polygons. So all polygons, it's 360 degrees no matter what. There's no if this, if that, what about this, what about that. It's 360 degrees. So a hexagon has 360 degrees as their sum of exterior. A quadrilateral, 360 degrees. An 18gon, 360 degrees. Doesn't matter, it's 360 degrees. Now to find one, and again, this only works on regular polygons. You're going to take the total, which this time is 360. It doesn't change. You're going to divide by the number of sides. So since a hexagon has 6 sides, you take 360 and divide by 6. That gives you 60 degrees. So that means this exterior angle is 60 degrees. This one is 60 degrees, this one is 60, and so on. So all of these outside angles are 60 degrees. Quadrilateral, well, that means it's got 4 sides. So 360 divided by 4 is 90. So easy peasy. All right, so now we have a regular pentagon So we're going to find the sum of exterior. Well, that's 360. That's the one that never changes. One exterior is the total divided by the number of sides. So that's 72. So that means this outside angle here is 72 degrees. The sum of interior, so 5 minus 2 is 3. 3 times 180 is 540 degrees. And now one interior is your total divided by the number of sides, so 108. So now this angle, and here is 108 degrees. All right. Oh, what happened here? All right. So now we have a trampoline. It's shaped like a regular dodecagon. So what we can conclude from the given information, that should say given, I don't know what happened to my n, is that n is 12. So we know we have a 12-sided figure. So we're going to find the measure of each. Each means one interior angle. So I need to find the total. So 12 minus 2 is 10. 10 times 180 is 1800. So this is my total. So now I need to divide by how many sides there are, and I get 150 degrees. To find one exterior, you take your exterior total divided by the number of sides, and that gives you 30 degrees. So one interior is 150, one exterior is 30. All right. So now the sum of the measures of the interior angles of a convex polygon is 900. So I'm telling you the sum is 900, and I want you to find the number of sides. Well, n minus 2 times 180 gives you the sum. Well, if you know the sum, then set it equal to the formula. And as confusing as this looks, that's only 2 steps. So the first thing you're going to do is you're going to divide both sides by 180, because I'm multiplying by 180. So I get 5 equals n minus 2, and then add that 2 so that you can get n by itself. And you find out that n is 7, so this is a heptagon. So 2 things. When you know the sum, you're going to divide by 180, then add 2. So step 1, step 2. Now, when you have a triangle, it's got 3 angles. If I give you 2 angles, you add and subtract from 180, because the total of a triangle is 180. Well, when you're doing one of these, you have to find the total so that you know what they're supposed to add up to. So this is 1, 2, 3, 4, 5, 6. So since n is 6, that means 6 minus 2, which is 4. 4 times 180 is 720. So the total of all 6 angles should add up to 720 degrees. So now, I know that if I add all these together, 150 plus 140 plus 130 plus 120 plus 90 equals 630. So these 1, 2, 3, 4, 5 angles have to add up to 630. Well, I need to find this one. So I know that all together it should add up to 720. So if I subtract what I know, then that gives me 90 degrees, which means x is 90. So the total is going to change depending on your figure. If it's a triangle, your total is 180. If it's a quadrilateral, your total is 360. If it's a pentagon, your total is 540. So you have to count the number of sides so you can determine your total. What happened to all these? Okay. Well, here we're dealing with exterior angles. So since I have exterior angles, I know they have to add up to 360. So if I add them all together, I know they have to add up to 360. So 5x plus 260 equals 360. Subtract 260 from both sides, and then divide by 5. And I find out that x is 20 because it just says to find the value of x. If it asked me to go a step further, then I would know that this angle was 20, and 4 times 20 would be 80. So I would know the measure of all of the angles of this quadrilateral. All right, our last step here. All right, so we're going to find the measure of each interior angle of a regular octagon. That means n is 8. So here we have an octagon as well, so n is 8 for both of these. So find the measure of each interior. So to find the interior, I have to find my total. So 8 minus 2 times 180. So my total is 1,080, and I would need to divide by 8. So that gives me 135. Here, to find each exterior, the total is 360 divided by 8, which is 45. What is the relationship between the exterior and the interior? The relationship between the interior and the exterior is that, if you'll look, 135 and 45. The interior is 135. The exterior is 45. Notice that together they make a linear pair. So they make a linear pair. So a linear, and that is an E. So the interior plus the exterior equals 180 degrees. So if you know the angle, then you can take, so remember I told you back here that 360 divided by n gives you 1 exterior angle. Well, you can also take 360 and divide by 1 exterior angle, and it will give you, do it over here, gives you the number of sides. So those two formulas are kind of interchangeable. So 360 divided by the number of sides gives you an exterior. 360 divided by the exterior gives you the number of sides. So if you know the exterior, you can subtract from 180 to get the interior, or you can divide into 360 and get the number of sides. So a lot of information there. So I'll see you guys next time. Have a good day.